All right, chapter 1, section 1. So again, this comes from the ebook, which you have access to through WebAssign. When you click in WebAssign and you go to your class, like on the left-hand side, I think it was still, I don't know if it's still there. There's a little thing that says access to ebook. So you always have the book there for an extra set of reference. This is called lines in the plane. So we start with a lot of review. So slope is how steep a line is, okay? The variable for slope is a lowercase m. It is the change in y over the change in x. If I have two coordinate points, it is y2 minus y1 over x2 minus x1. It is also rise over run. And this little change in y and change in x, you will also see with a little triangle, and that means change in. So those little triangles will also mean change in y or change in x. You can see it in any of those. There are 4 different types of slope. If it's rising as we move from left to right, it's positive. If it's falling as we move from left to right, it's negative. If it's straight up and down, there is no slope or undefined slope. And this type of slope occurs if it's a vertical line, and the way we would graph or know to graph a vertical line is the equation is an x equals a number and there's no y in it. So if it said like x equals 2, for example, that might be graphed as this. There would be no y in the equation. And then the last type of slope is if it's equal to 0. And this would be a horizontal line. And this time it's a y equals a number and there's no x. So this might be like a y equals 2. Those are things you have to just have memorized, especially like if it's the undefined one, if it's a vertical line. It's not like you can plug in points there because you won't have both the x and the y. So you'd have to know vertical is x equals and vertical is undefined slope or no slope. So if you were to think about like a treadmill, if you've ever been on a treadmill, as you raise the number, as that number gets bigger, the bigger the number, the steeper it is. That's a positive slope. If you could get a decline on your treadmill, right, that would be a negative number. That would be your slope that's falling. And then if you could somehow get your treadmill straight up and down, like think there would be no slope or no grip to hold on. If it's flat, it's at 0. All right, there are 3 different types of equations you need to know in this section. The first and probably most popular is the slope-intercept. Everybody remembers this, which is y equals mx plus b. In this equation, the m is your slope, and the b is the y-intercept. The second one is point slope. And that equation is y minus y1 equals m times x minus x1. Any point on that line can get plugged in as your x1, y1, and then m is again your slope. And then the last one is standard form. And this is ax plus by equals c. In standard form, the x and y are on the same side. They are all whole numbers, so no fractions, no decimals, and x must be positive. Y can carry any sign, and so can c, but x has to be positive. So very rarely you will plug into standard form. You can usually if it's in standard form, it's like easy to get your intercepts out of, but you don't typically plug into standard form. What you might do is plug into slope, intercept, or point slope, depending on what you're given. And then the question might ask you to put it into standard form. This can also be called general form. Sometimes you'll see stuff like that. So a standardized test like an SAT or an ACT might ask you to find the standard form of an equation. And for that, you've got to get them both on the same side. No fractions, no decimals, and the x has to be positive. Do we remember all 3 of these? Any questions so far? All right, so example 1 literally says, find the slope of the line and then use by using the graph line and by using points in the graph. So two different methods to find the same answer. If you're given the line, and again, eventually we will call this rate of change, but if you're given the line and I want to count my slope, I can pick any 2 points and I can count my rise and my run. It doesn't matter which one I'm starting at and which one I'm going to. If I start here, let's say I start at that 0, 2, and I want to go to the 4. The rise would be a negative 2 because I'm going down 2, and the run 1, 2, 3, 4. So my slope would be negative 2/4, which becomes negative 1/2. If I'd gone the other way, my rise is 2, my run is negative 4. So I still get 2 over negative 4, which is negative 1/2. So the order in which you pick these does not matter. Then if I was given the coordinate points, so this one's 0, 2, and this one's 4, 0, and I wanted to find the slope given the points, I can make this x1, y1, and this x2, y2, and I get y2 minus y1 over x2 minus x1, negative 2/4, which is still negative 1/2. So no matter if you count it or you use the slope formula, you should still end up with that same slope. Again, we'll call this eventually rate of change. Questions so far? All right, example 2 says find the slope and the y-intercept and then graph it. So notice A is already in slope-intercept. B is in standard form. So let's do A first. What's the slope of this line? Negative 3, right? And fraction form, because we need rise over run, it'd be negative 3 over 1. And your y-intercept is what? 2. Remember, intercepts go in coordinate point form, so it'd be 0, 2. So then I'd start at 0, 2, and I count my slope. 1, 2, 3 to the right 1, or up 1, 2, 3 to the left 1. As long as you have 2 points, it doesn't matter which one you use, but you've got to have the 2 points at least to form your line. Good? Yeah? All right, B, if I wanted to find the slope, there's actually 2 options I can do. What's one? Good. I can rearrange it so that it's solved for y. So y equals mx plus b. And then whatever is in front of the x I can use. The shortcut would be a negative a over b. So the a is what's in front of the x. The b is what's in front of the y. If you have it in standard form, then your slope would be negative what's in front of the x over what's in front of the y. So if you want to just pull out the slope, that's a fast way to do it. I could have, again, also just rearranged it. So it would have been 2y equals negative 3x plus 6, and then y equals negative 3 halves x plus 3, because I'd have to divide everything by 2. Now, if I solved it and put it in point slope form, into slope-intercept form, it's easy to spot your y-intercept. What's your y-intercept? 3, so 0, 3. If I kept it in standard form, think about what we just did in the last section. If I had this equation, what's a quick way to find the y-intercept without having to move it around? Yes, but how else could we do it? Think about what we just did for intercepts in the last section. What did you do? If I wanted you to find the x or the y-intercept, what'd you do? Last section, go back 2 days. What did we do to find the y-intercept? Make x 0. So if I make this 0, this sucker's gone. And then all I have to do is divide by 2, and I get y equals 3. So 2 different ways to find the slope and the y-intercept. How you choose to do it is completely up to you. But it's not that there's only one way to do it, okay? All right, now I'm going to graph this. So this time I'm starting at 0, 3. and my slope is negative 3/2. So I'm going down 1, 2, 3 to the right 2, or up 1, 2, 3 to the left 2. Again, I only need 2 of those points, but you can go either direction. We good so far? Questions? All right, example 3, find the equation of the line with the given information. So notice it didn't tell me what form to put it in. If it does not give you specific form, then the default form it wants the answer in is slope-intercept. Or y equals mx plus b. If it tells you to put it into standard, then you're putting it into standard. If it tells you to put it into point slope, then you're putting it into point slope. But if it doesn't mention it, then your default is slope intercept, or y equals mx plus b. So if I look at A, what kind of information did I give you? What does M represent? Slope. So I have the slope, and it passes through 3, negative 2, which means I have the slope and I have the point. I'm going to show you 2 different ways to do this the first time, and then you pick, okay? One way is to plug it into point slope. Me personally, if I'm given the point and the slope, I pick this method. You don't have to, but I pick this method, which is plug it into y minus y1 equals m times x minus x1. So this would be my x1 and my y1. And I'd get y minus a negative 2, which becomes plus 2, equals negative 3/4 x minus 3. So I plugged in the point and I plugged in the slope, and now I want to solve for y. I'd get y plus 2 equals, distribute here, negative 3/4 x plus 9/4. And then subtract the 2, and I get y equals negative 3/4 x. 2 becomes 8/4, and this becomes plus 1/4. So that's one way to find it. If they give you point slope, you can plug it into point slope. The other option is to plug it into y equals mx plus b, solve for b, and then take the m and the b and plug it back in again. So I think the benefit of doing it the first way is you don't have to plug it back in, but some people like this method because they like remember y equals mx plus b better. I don't care how you do it. Oh, we're lagging. All right, so now I'm going to take that coordinate point. I'm going to plug it in as my x and my y. So my y is negative 2 equals my m, which is 3/4, times my x, which is 3, plus b. So when I'm using the slope-intercept method, I'm plugging in the slope and the point because I don't have the y-intercept. So then I get negative 2 equals 9/4 plus b. Thank you. Negative, thank you. And then I would add the 9/4. I still have to convert that negative 2 to negative 8/4. B is still a positive 1/4. So you get the same answer either way for B. But with this method, you got to take now and plug back in. The y stays as y. The m, negative 3/4. The x stays as x, and the b is what you just found, which is the 1/4. I don't care which method you pick. You pick whichever one you're going to be make the least amount of mistakes with, okay? But obviously you need to know one of those ways. Questions on that one? Okay, now look at B. What's different from A to B? What did I not give you this time? I didn't give you the slope, right? But we know how to find the slope. Yes, if I'm given 2 points, I find the slope by doing y2 minus y1 over x2 minus x1. So 7 minus 1 over negative 8 minus a negative 8 is 6 over 0. What happens when zero's in the bottom? Undefined. Can you plug undefined into an equation? No. So this is where your recall has to happen. If the slope is undefined, what kind of line is this? Vertical. If it's vertical, which variable does it have? X, not the Y. So I have to just do X equals and then look at my X values. They're both the same. If I went to grab the Y values, if you made a mistake and said it was Y equals, I hope you'd get confused because the Y's are different and how would you know which one to pick, right? If the X's are the same, then I should be able to easily figure out that I just grabbed the X. If you forgot, you could obviously plot those points. You would see it's a vertical line in which the X does not change. So that could help you too. But that is one of those things that you can't plug in undefined. So you would not be able to find the equation if you didn't know what type of graph that was, which then leads to what type of equation. Still with me? Good? Yeah, sure. All right, then we've got parallel and perpendicular, okay? Parallel lines have the same slope. Perpendicular lines have slopes that are the opposite reciprocals of each other. So if I told you the slope of a line was 2/3, the slope of a line that is parallel to it is also 2/3. And the slope of a line that's perpendicular, we would change the sign so it would become negative, and we would flip the fraction so it would become 3/2. Think about your special cases here. If I told you the slope of a line was 0, which would be a horizontal line, what's the slope of a line that's parallel to that? Parallel. Also 0, right? What's the slope of a line that's perpendicular to it? Undefined. Okay, because if I flip 0, like let's say this is 0/1, if I flip that, 0 is now on the bottom, which makes it undefined. Okay. The symbol for perpendicular is the little upside down T, if you remember from geometry. So that you don't have to, 1, remember how to spell perpendicular, 2, write the whole word out. And parallel is 2 lines that look like they're parallel. That's the symbol for parallel. All right, example 4 says determine if the lines are parallel, perpendicular, or neither. So A, line 1 says 3y equals x minus 6, and line 2 is y equals 3x plus 1. What would I have to do with the first one in order to figure out the slope? Divide everything by 3. So what's the slope of line 1? 1/3. Good. What's the slope of line 2? 3. Are these parallel, perpendicular, or neither? Close. Remember, perpendicular has to have 2 things. Opposite and reciprocal. We've got the reciprocal part, but not the opposite. So this is neither. For B, we're going to find the slopes. So x1, y1, x2, y2, I get 9 minus a -1 over 5 minus 0, 10 over 5, which is 2. Line 2, 1 minus 3 over 4 minus 0, -2/4, -1/2. Are these parallel, perpendicular, or neither? Good. This time they're perpendicular because opposite reciprocals. Questions so far? All right. Last example is 5. It says write the equation of the line through the given point that is A, parallel, and B, perpendicular to the given line. So there are 2 questions built into one here. A, where the lines are parallel, and B, where the lines are perpendicular. The information given to you is the slope of an original line. The equation of an original line and the coordinate point of where this new line that they're talking about passes through. So I have my point, which means I have my x, y. What I need from the original is its slope. So what's the slope of 3x plus 4y equals 7? Negative 3/4. This time it's definitely easier to do negative a over b, okay? And that's all I need from it. I don't need the b. So I would recommend the shortcut, negative a over b. If you don't remember it, then you solve for y. So this is the slope of my original line. If A wants the equation of a line that's parallel to that, what slope do I use for part A? Negative 3/4. I keep it the same. If B wants the equation of a line that's perpendicular to the original line, then what slope am I using for B? Positive 4/3. So if it's parallel, we keep it. If it's perpendicular, we make it the opposite reciprocal. Still with me? All right. Now, this is where people mess this up. Once you take the slope out of this equation, we're done. No other piece of information carries over. And these two are two different equations. So I'm going to solve for A, and I'm going to get an equation. The B on that A does not carry over to the B that I would use for the second one. They're two separate equations. So for both of these, I'm using the slope which we just found and this coordinate point. So I'm going to do one using slope intercept, and I'm going to do one during doing point slope, but remember you get to pick which method you want to use. So for this one, I'm going to say I'm going to solve using y equals mx plus b. I'm going to take the coordinate point that I gave you, which is 7/8. The slope is 3/4. The x is negative 2/3. So I plugged in the x and the y and the m. I'm going to get 7/8 equals positive, well, this cancels and this simplifies, positive 1/2. And then I'm going to subtract that 1/2. And I get 7/8 minus 4/8. And b is 3/8. And then I take and plug back in the m and the b. So y equals negative 3/4 x plus 3/8. And then again, I am done with that equation. People make the mistake of taking this 3/8 and carrying it over to part B and saying that's your y-intercept. That is not right. These are two different equations. The y-intercept might be the same, but more often than not, it is not. So now I start over again. This time, my slope, because it was perpendicular, is the 4/3, but I still use the point they give you, which is negative 2/3 and 7/8. And this time, I'm going to do point slope. So y minus y1 would equal m, which is 4/3, times x minus x1, which is negative 2/3, so that becomes plus 2/3. I would distribute the 4/3 here and here. I would add the 7/3. 7/8, just kidding. I rewrote it. Wrong, thank you. All right, that should have been 7/8 plus 7/8. Okay, then these gone. Y equals 4/3 x. And then I have to give this a like denominator. So 8/9 plus 7/8. Like denominator here, they're both going to be over 72, right? So times 8 times 8 times 9 times 9. And I get 64 over 72 plus 63 over 72. And then I'm going to add these together. and I get 127 over 72. I would see if I could simplify that. So like, obviously they're not both divisible by 2 because they're not even. If you want to do your trick of your 3s, if I add up the digits, 1 plus 2 is 3, plus 7 is 10. If they were both divisible by 3, they'd be divisible by 3, okay? That's not happening, which means that big nasty number stays exactly as it is. I don't need you to put this into mixed number form unless you're graphing it. Obviously, if you're graphing it, you would need to be able to put that into mixed number form. So notice they have different B's. The B's are not going to carry over, and I would say that's the most common mistake made here, okay? When it comes to test time, 1, either people make some weird mistakes with fractions when they start doing the least common denominator and all that stuff. 2, they will, once they find that 3/8, they will carry this over. They will change the slope to be the opposite reciprocal, but then they will carry over the 3/8, and that is not correct. You got to find the right y-intercept. Questions on anything we did today? Okay, I'm going to walk you through how you can send this to Notability. So the first thing I would do is tap and hold on the name so you can copy the name of the assignment because it'll be easy to paste later. Then I'm going to arrow up on the top. I'm going to scroll to where it says markup. Now I'm going to arrow up again, and I'm going to send it to Notability. From the note title, I can paste in the title that we copied. I'm going to put it in the right folder, and I'm going to import it. And then when you go to Notability, you'll see the whole file. The other thing you want to make sure at the end is that you replace your score up here. The easiest way to get the entire box shrunk down is to split your screen. So if I want to take 2 screenshots, I can take a screenshot as it is, then scroll over and take a screenshot with all the boxes. But if I swipe up and I open up another app next to it, it's going to shrink the box down and give me all the boxes in one picture. Then I can screenshot this and pull it into my note to submit.